Okay. So the two previous exercises says on the two previous exercises we saw how we solve inequality with polynomials. Now we are going to be working with rational functions in inequalities, and the method is going to be the same. We are going to identify the boundaries. We are going to use the number line to help us to identify the regions and the signs, or the sign of the rational function in this case, of each region. Okay, the difference here is that when we are going to find the boundaries, now we need to take into consideration the numerator. From the numerator, we are going to find the zeros of that polynomial in the numerator, and we need to take into consideration the denominator. Okay, and here in the denominator, what we are going to find is the restrictions. All right. Okay. So from the numerator, we find the zero of the polynomial that is on the numerator. This is x equal 0. Right? From the denominator, we go and find the restriction not equal to 0. It means that the domain has a modification. The domain does not include -7. All right? Before we continue, look the structure that we are working. The rational function, everything is on the left side and 0 is on the right side. Okay, you will see another exercise where this structure is going to be different, and you will see what we need to do first before getting to the boundaries. Okay, but if we have this, everything on the left side and 0 on the other side, on the right side in this case, we go and identify the boundaries immediately. All right, so with that, we do the same. We do the number line. So -7, 0. In this occasion, yeah, -2. Thank you, Richard. Yep, my bad. It's -2. Okay, sorry for that. I made a mistake. Thank you, Rachel. The 0 of the numerator is -2, not 0. I don't know why I put 0 there. X equal -2 is the 0, and x not equal -7 is the other boundary that we are going to use. Okay, even though we are using a not equal, okay, we are going to take into consideration that -7 there. Okay, I think everything clear so far, right? Mm-hmm. So we are going to treat both -7 and 2. Oops. They are the boundaries here. So in this occasion, because we have now we are working with a rational function, I won't recommend to use the multiplicity here, because sometimes depending on the exercise, sometimes it gets confusing. Okay, the only thing that you need to remember that here a -7, in any restriction we could have, or a vertical asymptote or a hole in the graph. The important is that the y value at -7 here is going to be undefined. This is important because sometimes we are going to include zeros, like in this one. We are looking for greater than or equal to 0. Okay, so sometimes the boundaries are part of the solution, but for the case for the restrictions, since the value is undefined, you are not going to include in any case the boundaries, the restrictions of the domain. All right. We know that at -2, the y value is 0. This is the only thing that I'm going to use here. I know that the -2, the y value is 0. The function value is 0. Okay. I'm not going to use cross or the multiplicity here. Okay, because it will make things more complicated than it is. So in this occasion, what you want to do is to evaluate each region. The one that I'm going to select from region A is going to be -10, B is going to be -5, and C is going to be 0. So now let's evaluate everything here. So for x equal -10, so we plug in -10 here. And again, the value is not important. It is, what is important is the sign. So this is how I simplify this, as we know that 10, the magnitude of 10 is greater than 2, so 10 negative plus 2, that's going to be negative. And negative at the bottom as well in the denominator. So the sign is going to be positive. Two negative that are dividing, we divide to the negative sign can cancel, and we have a positive value here. So region A is positive. -5, we do the same. Let me change 10 for 5. So we have negative, we have positive at the bottom, the sign is negative, so the region is negative. And the other one, region C, we test with 0, the x value equal to 0, so we have positive, positive, and positive. Okay, so we are looking for greater than, I think I just can zoom to here. We are looking for greater than 0, so the two regions are A and C. Greater than or equal to 0, A and C. Help me to write the solution. And remember that -7 is a restriction and -2 is a 0. How would you write the solution here? Okay. So how would you write the solution for this exercise? From negative infinity to negative 7. Union from 2 to positive infinity. That's correct, Rachel. Thank you. Careful. Negative 7. The y value at negative 7 is undefined, so we do not include negative 7, but we do include negative 2 because at negative 2 we have a 0, and we have greater than, equal, all 0, or greater than, equal, or equal to 0. So there you have it. Again, you should break down these exercises. This is going to be very easy, but you need to understand what's happening in the background of a polynomial of rational functions. Okay, here is everything work. See that in this case I went through the evaluation to all the regions. Okay, any question? All right, so let's see more complicated exercise. And the reason and why this is more complicated, well, this is what we have. A rational function on the left side and a polynomial on the right side. So let me put this below because we are going to use it here. So what would you say that is the issue here? What's the problem? Or what we need to do first before going through the 4 steps to solve any inequality? One side must be 0. Careful with this. I'm going to use parentheses to enclose each part here of the inequality. So see that I'm considering the numerator, or the polynomial denominator as a whole. We have 2 terms, but I take into consideration those 2 terms as one concept. The denominator of the 2 terms, I'm taking them into consideration as one concept. And the polynomial on the right side, I'm taking both terms into consideration as just one concept. Okay? Why am I saying this? Because now we want to have the right side equal to 0 and x minus 1 on the left side. Okay? So what we are going to do, in order to do that, what we need is to subtract both sides by x minus 1 completely. Okay? And the part that sometimes is confusing here is how to manage the signs and where to put negative x minus 1 in the left side. Okay? So we know, since we are considering x minus 1 as a whole, right? So this is positive, the one that is at the top is positive, and the one at the bottom is negative, so we cancel completely that part. All right? So I'm going to copy this, if I can. Okay. Let me rearrange this, okay? So on the right side, we have canceled x minus 1, right? And then on the left side, we have brought minus x minus 1, okay? Careful, do not bring yet x minus 1 into the fraction, all right? You need to remember that this rational function is a fraction, and in order to subtract fraction, we need to have a common denominator. There is no common denominator here. Okay. Okay. So now we are in this situation. Let's forget about each component here just for a moment from each polynomial. Let's forget about each polynomial here for a moment. Let's work with a subtraction of a fraction between a whole number, integer and a fraction. Okay, let me put this here just a moment. Let me set up this. Okay. So A, B, and C are variables that are representing a real number, right? So you can think of them as any number. Okay. So we have a fraction. We have two terms. We have a subtraction here where the first term that we have here is a fraction, A over B. And the second term here is representing an integer. Okay, C is representing an integer. We cannot go and subtract directly A minus C here because there is no common denominator. We know because C is an integer, its denominator is 1. So how are we going to combine these two terms here, the fraction and the integer? So we multiply together b times 1, so that's just b. So b is going to be the common denominator. A times 1 is just going to be a. Careful with the sign, okay? So we have a subtraction, so it's going to be a subtraction here, and then C times B, or B times C. Okay. This is not part of the written word. This is something that is going to help you to remember this. And then I'm going to use colors. Let's bring this into different colors so you can identify each part. So you will know all right. When you have this situation, okay, think of each component of this rational function and the polynomial here on the second term as one component. Okay, so for example, 3x plus 4 is represented by a here. Okay, this is not part of the written word. This is something that you need to remember to combine these two terms correctly. So 3x plus 4 is a, x minus 4 is b, x minus 1 is c. Okay, so the denominator here is 1. So we are going to use, basically, let's call this a formula. Okay, we are going to use this formula to combine this. So I'm just going to bring this and I'm going to change a with 3x plus 4. This need to be bigger. X minus 4. And C, let me put this correctly. Any question on what I just did here? Does that make sense? Any question on this? Okay, so no question. Okay, so now the next step will be, this is still something that is difficult to identify the boundaries. Okay, yes, we can identify the boundary of, or the restriction of the rational function, but the numerator is still messy, okay, for lack of a better word. So let's multiply everything that needs to be multiplied. Let's combine the like terms and let's see what happens. I'm going to continue carrying the parentheses. Why? Because there is a multiplication, there is a negative sign, and I want to know what's happening with that negative sign. Okay, careful with that. Okay, forget about everything. Let's focus on just on these two linear factors that are being multiplied together. Help me with this distribution. What will be the answer? What would be the multiplication between x minus 4 and x minus 1? That's correct, Amanda. X squared minus 5x plus 5. Okay, I have here plus 4. Yeah, that's correct. Let's just make sure that everything here correct. Rachel, yeah, you are correct. Amanda, the constant term is, the value of the constant term is 4, not positive 5. I believe you add those together. For the last term, we multiply the outer terms here. So negative 4 times negative 1, we got positive 4. Okay, yeah, but sometimes this could be confusing. If we do that from our mind, we always want to make sure that we are doing correctly. Okay, so the correct answer is x squared minus x5 plus 4. Okay, and that's okay, Amanda. I thought that it was 5 as well, but it's a common mistake. Okay, why am I carrying this parenthesis here? It's because this negative here. That negative now is like multiplying this result that we got here by negative 1. Okay, so now I'm going to drop the parenthesis because negative times x squared is going to be negative x squared. Then the negative transform into a positive, so negative 1 times negative 5x, positive 5x, and then negative 4. Okay, careful with this. These are the common mistakes that will hurt you the most, because if you make a mistake here with just a negative at the beginning of this exercise, then the entire solution is going to be incorrect. And unfortunately, since this is the beginning, you are just setting up the inequality, you are going to get wrong numbers and you are going to miss a lot of points. So careful with this part. Make sure that you double check everything here. Now we can combine the like terms. So 3, 5, 8x, positive 4, negative 4, they cancel each other. X minus 4x. And this is something, this is what you want. This is the structure that you want to work with. All right. So you can stop here. You are already have the exercise ready for the step to solve the inequality. Amanda, that's a good question. Why will not cancel x minus 4? X minus 4, let's see if we can cancel x minus 4. Okay, let's see what happened. Remember that this is a rational function. Let's do the let's try to do a simplified version of the rational function. Let's see if we can do that. Okay. Okay. Before doing that, you can stop here, and then this is good enough to start working with inequality. I'm going to show you what I want to do, what I like to do with this type of exercises, where I have a negative in front of the leading term in the numerator. Okay, what I do with that negative, how I can put this in a way that will help me to continue with the exercise. Okay, if you want to start working from this step, the boundaries, the number line, the evaluation, that is going to be correct. That's going to be okay. Okay, but I'm going to show you what I like to do, and this is just extra steps. I seen that there is a common factor in the numerator. That common factor is x. All right, I know that just taking x from the numerator, factoring out x, I'm going to have a second factor with negative x plus 8. I do not like having a negative in front of my leading term. So what I'm going to do, I'm going to factor out also the negative. What is the effect of having the negative here in front? Well, that I flip all the signs inside this factor here. Okay, so now I have positive x minus 8. Okay, and this is just me playing with the algebra here, just to make this exercise the way I prefer. Okay, but you don't need to do this, it's just a step. Okay, and now below I have x minus 4. Now let's see if we have a common factor that we can cancel here, and there is none. Okay, so let me put all the factor between parentheses. So x minus 4, there is no common factor here, so we can cancel x minus 4. Okay, so that's a good question, Amanda. Okay, but always make sure that you have, if there are any common factor, then we can simplify further the rational function. In this case, that's the most that we can do. I'm going to do another thing more. Okay, I do not like this, I do not enjoy. Okay, I mean, what we cancel when we made it equal to 0. Okay, Amanda, let me see. I mean, why we gonna cancel when we made one side here? Okay, got it. Why we did not cancel x minus 4? Part of the reason of that is that x minus 4 is the denominator, okay, of the rational function. Maybe you wanted, okay, I think I know. Okay, got it. Let me finish with this process, and then I'm going back to your question, Amanda, because I know, I think I understand now your question. Okay. All right, so this negative here, I do not enjoy having a negative there. Okay, it will confuse me when I'm doing the evaluation, but that's just me. What I'm going to do is you multiply both sides by -1, then you are going to cancel the negative, because that negative here is like having this negative here in front. All right, so multiplying both sides by -1, you can cancel that. But careful, we are working with an inequality. What happens when we multiply inequality by -1? What happens when we multiply inequality by -1? By a negative value. Let me be more explicit. So what I'm doing here is multiplying everything here by -1, and this 0 is going to be 0, but I'm multiplying this also by -1. What is the sign flipped? Yes, that's correct. So now the sign is greater than equal to 0. Okay, and this is the structure that I want to work with. Okay, but you can do all that. You can do the same with this structure. If you just stop here, that's good. Okay, I'm going to continue working with this structure, but you can practice then with this one to see that you are going to get the same results. All right. Okay, so Amanda made a good question. And the question Amanda made is, Amanda, correct me if I'm wrong, why we just don't multiply both sides of the equation on the inequality by x minus 4? That way we cancel out this denominator and voila, there's no fraction. What's the problem with this? Okay, Amanda, I like your question because yes, this is, we are tempted to do this because we are used to see a denominator. Let's cancel that out, that denominator, and that we don't need to deal with fractions. This is going to be okay when we are working with equations. The problem here is that we are not working with equations, so we have an inequality. No, Amanda, eventually yes, you can make the right side equal to 0 because you can subtract everything on the right side and put it on the left side. The problem here is that, do we know the sign of x minus 4? Is x minus 4 negative or positive? Is that something that we can know? We have a variable there, right? Is x minus 4 positive or negative? The answer to this question is we do not know. Okay? Because x minus 4 is representing a value. It could be positive or it could be negative. When we multiply both sides by x minus 4, knowing that it could represent a positive value or a negative value, then what will happen with the inequality sign? Because we are taking into consideration both the positive and the negative representation of x minus 4, we know that for the negative, this inequality sign will flip, will change its direction. So when we are working with an inequality, it is not possible to multiply by both sides of the inequality by a factor that we do not know its sign, or that it is a variable that represents both signs, positive and negative. So you don't want to do this to cancel this denominator. That is the reason why we need to do all the step that I just showed. Because we are not allowed to multiply both sides of the inequality by x minus 4, because x is a variable and we do not know, or x is representing both positive and negative values. So the rule of the inequality is that when we multiply by a negative value, that the inequality direction changes, need to be taken into consideration here. So we are not going to do this, okay? All right. Okay. Okay. Any other questions? So now that we have that, this structure, we are going to be able to do the steps, boundaries. So we have the zeros. So we take the numerator into consideration. So the zeros are x equals 0 and x equal 8th. The restrictions is just 1. X minus 4 can't be equal to 0. Hence, x can't be positive 4. We go to the number line. That's not the number line. We plot those. So 0, 4, 8. Oh, that's not what I want to do. And now we are going to evaluate each region. All right, here I always will make sure that I know which one here is the restriction. The restriction is positive 4, so here I have undefined value. This is 0 and this is 0. This is always going to help me to understand that 4 is not part of the domain, so I cannot take 4 as part into consideration for the solution. From negative infinity to 0, from 0 to 4, from 4 to 8, from 8 to positive infinity. Here I'm going to test for negative 1. Here I'm going to test for positive 1. Here I'm going to test for 5. And here I'm going to test for 8. Testing for each of them, I'm not going to do step number 3. You will need to know. Maybe I'm going to do just for A, okay? Just to show you the complete process. But I'm not going to do the test for each region, so because you already know how to do that, I'm just going to show you just one evaluation. What is important is the sign. Okay, so here we have a multiplication of two negative sign on the numerator that becomes a positive, but then at the division by a negative. So this is a negative, so this one is negative. Repeat the same process, the evaluation for each side. This one is positive, this one is negative, and this one is positive. Okay, again, I'm not doing all the evaluations, I'm just taking the results and putting them here. But remember that in your work you will need to evaluate here for each region. And since we are looking for greater than, now we are looking for greater than. Initially we were looking for less than, but because of this, I was able to transform the exercise into a greater than or equal inequality. So it's going to be, the solution is going to be from 0, but I'm going to include 0 because here I have an equal sign. From 0 to 4, I'm not going to include 4 because at 4 we have an undefined value from 8 to positive infinity. Okay, and that's how you solve this exercise. Any question? This one, the written work for this one was all this. When you have an initially the structure of the exercise is not the one that we want, like this one is where you are going to be working the most. Okay, if you don't have the factor form of a polynomial, then you need to do the factorization of that polynomial, hence you will be working more. If it's a rational function, you don't have the structure where we have on one side the 0, then you will need to do an extra step where you are going to rearrange the exercise structure in order to have a structure that will help you to solve the exercise. Okay, so all this is written word, all this, but the formula here not. Okay, everything else is part of the work. Remember that you can stop at this one, at this step. Okay, but if you are like me, that I prefer to have my the structure of the exercise in the simplified version possible, then you will do a few extra steps, and then you're going to apply the 4th step that we do to solve the inequalities here. Okay, any question? That's all for Unit 8. I wanted to go over a few concepts of Unit 9. I know that today have been a long class, but next, yes, Tricia, I can go down. Next Wednesday you have quiz number 4. Okay, and quiz number 4 you are going to be working with rational functions and inequalities of polynomials and rational functions. Okay, so this Wednesday we are not going to meet, but you need to submit your written work for Unit 9 on Friday. So since we are not going to have a class before Unit 9, I want to go over a few exercises of Unit 9. They are going to be very quick. They are going to help you to prepare you for solving exercise analysis. Okay, so I'm going to continue recording the class, so you have those 2 exercises in the YouTube channel. Okay, but if you don't want to go start working with Unit 9, that will be all for today. If you want to stay to see me working with Unit 9 today, just stay. I'm just going to solve 2 exercises, and then that's going to be all for the class. Okay. Richard, do you have the solution there? Okay, perfect. Okay, for Unit 9, when you want to find the inverse function, this is what you are going to follow. So this is a rational function that we have. We have g of x, and we want to find the inverse function of this. So the steps are the following. Change the function notation to y. Since we are working with the inverse function, flip y, and x. So now all y's become x and all x becomes y. Now solve for y. So that means that you are going to isolate y in one side of the equation. So here we have an equation. This is an equal. So we are able to multiply by the denominator because we have equal sign. So I'm going to multiply both sides by x by 5y minus 4. All right. So we cancel out this denominator, and now we have 5y minus 4 x equal 3y. In this step, put all the y or the term that contain y in one side of the equation. Before doing that, sorry, we need to distribute x with this linear factor. So it will be 5yx minus 4x equals 3y. Now put together all the term with y in one side of the equation. So that means that negative 3y is going to be here and positive 4x is going to be on the right side. Okay, subtracting by 3y on both sides of the equation and adding by 4x on both sides of the equation. Because now we have all terms with y, we can factor out y from the left side. So 5x minus 3 equal 4x. Y equal 4x. We divide both sides by this factor. Let me do that. Both sides of the equation are divided by 5x minus 3. So we cancel out this factor from the left side, and now we have y equal 4x over 5x minus 3. At this point, you will have finished. The only thing that you will do is to change the y notation to the function notation. In this case, you will use the inverse. Okay, the inverse notation. You will see the meaning of that negative in front between g and x. Okay, it means the inverse function. Okay, and that's how you find the inverse of that function. Okay, those are the steps. I'm not going over all the details about unit 9. I'm just going to I just showing you this exercise key exercise from that unit. Okay, from the puzzle you are going to get the entire details about unit number 9. Unfortunately, we don't have like just one day for unit number 9. Okay, but this is something that you want to know how to do it. If you have questions about unit number 9, send me an email and I can send you. We can find a way. If you need to meet or you have questions, then we can find solution for your question or answer for your questions. Okay, so that is what you have seen is how we find the inverse function, okay, of a rational function and one-to-one function. Okay, the detail about one-to-one function are not important for our course. The most important here is that you know how to find the inverse function. And these are the steps. And this is just an example, okay? But you want to follow those steps. The other thing that I want to discuss here is the composition of functions. This is not difficult, but it is confusing. It is confusing because of the writing. It's like putting a function, it is literally putting a function inside a function. So it gets messy sometimes. But how can we do this in the easiest way. Okay, when you see this notation, this means f composition of g of x. The meaning is that we are going to put in the input group g of x. In the input group of f goes g of x. Okay, so now we are treating the variable, the input, which is usually x for f. Now the input is just an entire whole and different function, and that is where this thing gets messy. But what I like to do is to, okay, so x now is g of x, so I'm going to follow the definition for the function f. I know that f is equal to times x plus 5. Well, all the x are going to be g of x. Okay, all the x's are going to be g of x. Okay, and then I know that the definition of g of x is square root of x minus 2. So now what I'm going to do is to change g of x with its definition, which is square root of x minus 2 plus 5. And that's it. Okay. Though, yes, this is a very quick example of different cases that you are going to see. Okay. But I don't want to take too much time. I want you to get ready for the quiz of this Wednesday. Okay. So at least you have 2 examples for unit number 9. But any question that you might have, let me know and we can address those questions before Friday. Okay. Thank you, everyone. Thank you for participating on today's class. Okay. Any question that you might have, send me an email. Wednesday we don't have class. It is a quiz day. Okay. Have a good rest of the day, everyone. Bye bye.